Hermann Göring sat in his plush armchair at Carinhall, his sprawling hunting estate 50 miles north of Berlin, reading the intelligence summary with what could only be described as amusement. The date was May 16, 1940, and the report detailed something the Reichsmarschall found genuinely laughable. American President Franklin Roosevelt had just announced to the United States Congress a goal to produce 100,000 aircraft per year for the Allied war effort. 100,000. Göring set down the paper and turned to his adjutant. "They cannot even make decent razor blades," he said, his voice rich with contempt. The comment would be recorded in multiple post-war accounts, repeated by those who had been present. It captured perfectly the German High Command's assessment of American industrial capability in the spring of 1940. The Luftwaffe, at that moment, was the most powerful air force in the world. German aircraft had swept Polish resistance from the skies in weeks. They had devastated French airfields and driven the British Expeditionary Force into the sea at Dunkirk. Messerschmitt 109s and Junkers 87s flew with near impunity over conquered Europe. German factories were producing aircraft at rates that seemed impossible just years earlier. Göring had every reason for confidence. His air force had demonstrated technological superiority, tactical brilliance, and overwhelming combat effectiveness. The industrial base supporting this force was operating at wartime capacity, turning out hundreds of fighters and bombers each month. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. And now, Roosevelt, leader of a nation that had not fought a major war since 1918, whose military ranked 19th in the world behind Romania, was claiming America could produce 100,000 aircraft per year. The number seemed absurd on its face. Germany, with its fully mobilized war economy and years of rearmament under National Socialist direction, was producing approximately 10,000 aircraft per year at this point in the war. Britain, fighting for survival and pushing its factories to maximum output, was managing roughly 15,000 per year. Roosevelt was claiming the United States, which had produced fewer than 6,000 military aircraft in all of 1939, could somehow increase production by a factor of nearly 20. The German intelligence assessment filed with the Oberkommando der Wehrmacht was dismissive. American industry was oriented toward consumer goods, automobiles, and commercial products. Converting such an economy to military production would require years, possibly a decade. American workers lacked the discipline of German labor. American factories lacked the precision tooling necessary for aircraft production. American engineers, the report suggested, simply did not possess the technical expertise to design combat aircraft that could match German models. The assessment was not based on ideology alone. It drew from real observations of American industrial capacity in the 1930s. The United States had built automobiles very successfully, but automobiles were not aircraft. The precision required was different, the materials were different, the entire manufacturing philosophy was different. A car factory could not simply be retooled to produce bombers. The Germans knew this from their own experience converting civilian industry to military production after 1933. Göring's confidence, shared throughout the German High Command, rested on observable facts. The Luftwaffe had defeated every air force it had encountered. German aircraft were superior in most categories to anything the Allies currently fielded. German production was accelerating under efficient central planning. The mathematical logic seemed clear. Even if America could eventually produce significant numbers of aircraft, and that was doubtful by the time those planes reached combat, the war would be over. Germany would control Europe. Britain would sue for peace or be invaded. The industrial capacity Roosevelt boasted about would be irrelevant. They believed this completely. The Luftwaffe's confidence in May 1940 was not misplaced arrogance. It was the product of systematic development, combat experience, and genuine technological achievement. Understanding why Göring laughed at Roosevelt's announcement requires understanding what the German Air Force had become by the spring of 1940. The Luftwaffe's modern incarnation began secretly in the 1920s, when Germany, forbidden by the Treaty of Versailles from possessing military aircraft, trained pilots in the Soviet Union under clandestine agreements. German aircraft designers worked through foreign subsidiaries. Military theorists developed doctrine. When Adolf Hitler repudiated the Versailles restrictions in 1935 and openly announced the Luftwaffe's existence, the foundation had been laid for years. By 1940, the Luftwaffe possessed approximately 4,000 combat aircraft organized into specialized units. The Messerschmitt 109, designed by Willy Messerschmitt's team in the mid-1930s, was arguably the finest fighter aircraft in the world at that moment. The E variant, which equipped most frontline squadrons in 1940, could reach speeds of 354 miles per hour. It climbed rapidly, dove quickly, and carried effective armament: two 7.92mm machine guns in the engine cowling and two 20mm cannons in the wings. German pilots who flew it praised its handling characteristics and combat effectiveness. The Junkers 87 Stuka dive bomber had become synonymous with German tactical air power. Its distinctive inverted gull wings and fixed landing gear made it instantly recognizable. More importantly, its ability to deliver bombs with precision against point targets, bridges, bunkers, artillery positions gave German ground forces devastating close air support. The Stuka's psychological impact was carefully engineered. Sirens mounted on the landing gear, called Jericho trumpets, screamed during dives, terrorizing troops below. The aircraft itself was not particularly fast or well-armed, but in the tactical role for which it was designed, supporting rapid ground advances against disrupted opponents, it was extraordinarily effective. German bomber forces, though less emphasized than fighters and dive bombers, included capable medium bombers like the Heinkel 111 and the Dornier 17. These aircraft could reach targets in Britain, carry respectable bomb loads, and defend themselves with multiple machine gun positions. The Junkers 88, originally designed as a bomber, proved adaptable to multiple roles and would serve throughout the war as bomber, night fighter, reconnaissance aircraft, and even anti-tank weapon. More than the aircraft themselves, the Luftwaffe possessed operational experience. German pilots had tested their tactics and equipment in Spain during the Civil War from 1936 to 1939. The Condor Legion, ostensibly a volunteer unit but actually a fully integrated Luftwaffe formation, had flown combat missions supporting nationalist forces. They learned what worked in actual combat, not in peacetime exercises. They developed close air support techniques. They refined dive bombing tactics. They discovered the importance of radio communication between aircraft. They came away from Spain with veterans who understood air combat at a level no other air force could match. The Polish campaign in September 1939 demonstrated the Luftwaffe's effectiveness at operational scale. German aircraft achieved air superiority within days. Polish airfields were struck in coordinated attacks that destroyed aircraft on the ground before they could mount effective resistance. Polish cities, most infamously Warsaw, were bombed into submission. The Polish Air Force, equipped with obsolete fighters and bombers, could not contest German control of the skies. The campaign lasted 5 weeks. The Luftwaffe lost approximately 189 aircraft to all causes, many from accidents or mechanical failure rather than enemy action. The Norwegian and Danish operations in April 1940 showcased German air power in combined operations. Aircraft transported paratroopers to seize key airfields. Fighters provided cover for naval forces. Bombers struck Norwegian and British positions. The campaign was a tactical masterpiece, demonstrating that air power could enable rapid conquest, even across water barriers and difficult terrain. The subsequent campaign in the West, the invasion of France and the Low Countries, beginning May 10, 1940, was unfolding as Göring read Roosevelt's announcement. Within days, the Luftwaffe had achieved air superiority over Belgium, the Netherlands, and much of northern France. French and British aircraft were being shot down or destroyed on the ground at rates that made sustained resistance impossible. This was the context in which Hermann Göring assessed American claims. His air force was winning, German aircraft were superior, German pilots were veterans, German tactics were proven. German industry was producing aircraft in quantities sufficient to maintain this edge. Against this reality, Roosevelt's promise of 100,000 aircraft per year seemed like the desperate bluster of a politician trying to rally a reluctant nation. It seemed like propaganda, not a serious industrial plan. Göring had no framework for understanding what was about to happen, neither did anyone else in the German High Command. They were about to discover that their assumptions about American industrial capacity were not merely wrong. They were catastrophically, existentially wrong. To understand how America would prove Göring wrong, it is necessary to understand what American industry actually was in 1940, not what German intelligence believed it to be. The United States possessed industrial capacity that was, in certain critical ways, unlike anything that existed anywhere else in the world. But that capacity was not immediately apparent to outside observers, and it certainly was not oriented toward military production. The American economy in 1940 was still emerging from the Great Depression. Unemployment remained high at approximately 14%, down from 25% at the Depression's worst, but still representing millions of idle workers. Factory capacity sat partially unused. The automobile industry, America's industrial crown jewel, had produced fewer than 4 million vehicles in 1939, down from more than 5 million in 1929. To German observers, this looked like industrial weakness. It was actually latent capacity waiting to be activated. The automobile industry itself represented something unprecedented in industrial history. Henry Ford's introduction of the moving assembly line in 1913 at Highland Park, Michigan, had revolutionized manufacturing. By the 1920s, American automobile factories were producing vehicles at scales and speeds that would have seemed impossible to earlier generations. Ford's River Rouge complex in Dearborn, Michigan, could transform raw materials, iron ore, coal, sand, rubber, into finished automobiles in less than 48 hours. Raw materials entered at one end, completed cars drove out the other end. The vertical integration was nearly complete. The production volumes were staggering. General Motors, organized by William Durant and later managed by Alfred Sloan, had developed a different but equally revolutionary approach. Where Ford focused on a single model produced in massive quantities, the Model T, and later the Model A and Vate, General Motors offered multiple brands at different price points. Chevrolet for the mass market, Pontiac and Oldsmobile for the middle class, Buick for the prosperous, Cadillac for the wealthy. This strategy required even more sophisticated production management, coordinating multiple product lines across multiple factories while maintaining quality control and profitability. Sloan's management innovations in the 1920s created organizational structures that could handle immense complexity. Chrysler Corporation, the youngest of Detroit's Big Three, had been founded in 1925 by Walter Chrysler, a former General Motors executive. By 1940, Chrysler operated major manufacturing facilities and had demonstrated its ability to engineer and produce sophisticated vehicles, including the innovative airflow models of the mid-1930s that incorporated advanced aerodynamics and engineering. These companies had developed something beyond mere production capacity. They had created systems for managing vast supply chains. The Rouge complex alone required coordination of shipments from hundreds of suppliers. Steel mills in Pittsburgh and Gary, rubber plantations in Liberia, copper mines in Montana, glass factories in Toledo. Each component had to arrive at the right time, in the right quantity, to the right location within the massive factory complex. The logistics expertise required to make this work was extraordinary, though largely invisible to outside observers who saw only the finished products rolling off assembly lines. American machine tool industry, less celebrated but equally critical, had developed alongside automobile production, precision metalworking machinery, lathes, milling machines, grinding, equipment, boring tools was manufactured in American factories in quantities that dwarfed production elsewhere. These tools were what made mass production possible. They allowed semi-skilled workers to produce components to precise tolerances, something that had previously required highly trained craftsmen. Companies like Cincinnati Milling Machine, Pratt & Whitney Machine Tool, and dozens of smaller firms had spent decades refining these technologies. The aircraft industry in 1940 was tiny by comparison to automobiles, but it existed and was growing. Boeing, based in Seattle, had developed the B-17 Flying Fortress bomber and was beginning production for the Army Air Corps. Douglas Aircraft in Santa Monica and Long Beach, California, produced transport aircraft and the A-20 attack bomber. Consolidated Aircraft in San Diego was developing the B-24 Liberator, which would become the most produced American bomber. Lockheed, North American Aviation, Republic, Grumman, Curtiss-Wright, dozens of companies with experience designing and building aircraft, even if their production volumes were modest by automobile standards. What German intelligence failed to appreciate was that the gap between automobile production and aircraft production was not as large as it appeared. Both required precision metalworking. Both required coordination of complex supply chains. Both required managing large workforces. Both required quality control systems. The specific technical challenges differed. Aircraft required lighter materials, tighter tolerances, and more sophisticated engineering in areas like aerodynamics and engine design, but the fundamental industrial capabilities were transferable. An automobile factory could not become an aircraft factory overnight, but it could be converted in months, not years, given sufficient resources and planning. Moreover, American industry possessed something no European industry could match: scale. United States in 1940 had a population of 132 million, compared to Germany's 69 million. American factories, even running at Depression-era reduced capacity, produced more steel, more aluminum, more machine tools, more of virtually every industrial product than German factories. The raw material base was larger. The energy supply was larger, with American oil production in 1940 reaching 1,600,000,000 barrels, more than all other nations combined. The transportation infrastructure, railroads, highways, inland waterways, could move materials and finished goods with efficiency that European systems could not match. Roosevelt's announcement in May 1940 of a goal to produce 100,000 aircraft per year was not a random number plucked from thin air. It was based on assessments by government planners and industry executives of what American industry could theoretically accomplish if fully mobilized. The 10 number seemed impossible to German observers because they were evaluating it against German industrial capacity. They should have been evaluating it against American industrial capacity, which was fundamentally different in both scale and character. Within months, America would begin demonstrating what that capacity actually meant. The transformation of American industry from peacetime production to wartime output did not happen overnight, but it happened with a speed that would have seemed impossible to anyone observing American industrial capacity in the 1930s. The process began before Pearl Harbor, accelerated dramatically after December 7, 1941, and reached scales that defied contemporary understanding of what industrial production could accomplish. The first major step came in May 1940, the same month as Roosevelt's announcement. The President established the Office for Emergency Management and, within it, the National Defense Advisory Commission. This body, staffed by industrial executives temporarily serving in government, began assessing what would be required to expand aircraft production. William Knudsen, President of General Motors, was brought in to oversee industrial production. He understood what American factories could do because he had spent decades making them do it. The initial challenges were substantial. Aircraft manufacturing in 1940 required specialized knowledge that automobile executives did not possess. The tolerances were tighter. The materials were different aluminum alloys rather than steel for most structures, magnesium for certain components, specialized fabrics for control surfaces. The assembly processes were more complex. An automobile had perhaps 15,000 parts. A B-24 Liberator bomber had approximately 1,450,000 parts, each of which had to be manufactured, inspected, and assembled correctly. But the automobile industry brought capabilities that aircraft manufacturers lacked. Detroit knew how to organize production lines for maximum efficiency. They knew how to break complex assemblies into simple, repeatable tasks that semi-skilled workers could master quickly. They knew how to manage supply chains across multiple states and coordinate delivery of thousands of components to arrive at the right moment. They knew how to train workers at scale, taking people who had never worked in a factory and turning them into productive employees within weeks. The first major conversion project began at the Ford Motor Company's new facility at Willow Run, Michigan. Henry Ford had been reluctant to engage in military production, clinging to his pacifist beliefs, even as war engulfed Europe. But his son Edsel Ford and company executives eventually persuaded him. In January 1941, Ford accepted a contract to produce consolidated B-24 Liberator bombers under license. The company would not merely assemble components manufactured elsewhere. It would build complete aircraft, engines and all, in quantities no aircraft manufacturer had ever attempted. Construction of the Willow Run plant began in April 1941 on a tract of farmland near Ypsilanti, Michigan. The facility would cover 3,167,000 square feet under one roof, making it the largest room in the world at that time. The main assembly building stretched 3/4 of a mile in length. The entire complex, including parking, rail yards, and support buildings, covered 670 acres. At peak operation, the plant would employ 42,000 workers operating around the clock in 3 shifts. Ford engineers approached bomber production the way they approached automobile production. They broke the B-24 down into sub-assemblies. Wings would be built in one section, fuselages in another, tail assemblies in a third. Each sub-assembly would move down its own production line, with workers at stations performing specific, repetitive tasks. The sub-assemblies would come together at the final assembly line where the aircraft would be completed. It was the same principle Henry Ford had applied to Model T production 30 years earlier, now scaled up to 4-engine bombers. The plant began producing aircraft in September 1942. Initial production was slow, just 1 aircraft that month, as workers learned their jobs and processes were refined. But production accelerated rapidly. By December 1942, the plant produced 31 bombers. By March 1943, production reached 75 aircraft. By August 1943, Willow Run was producing 150 B-24 bombers per month. At peak production in 1944, the plant would produce over 400 Liberators per month, more than 1 aircraft per hour during some periods. Similar conversions were happening across American industry. Douglas Aircraft expanded its Long Beach, California facility to produce C-47 transport aircraft, the military version of the DC-3 commercial airliner. At peak production, Douglas built 1 C-47 every 43 minutes. North American Aviation's plant in Inglewood, California, manufactured P-51 Mustang fighters, eventually producing more than 15,000 of these aircraft. Boeing's Seattle facilities produced B-17 Flying Fortress bombers, while Boeing plants in Renton, Washington, built B-29s. Consolidated Aircraft's Fort Worth, Texas plant, built specifically for B-24 production, covered nearly 4 million square feet. The facility employed more than 30,000 workers at its peak. Like Willow Run, it applied automobile manufacturing principles to aircraft production, treating complex bombers as products to be manufactured on moving assembly lines rather than handcrafted in small batches. The workforce transformation was as remarkable as the physical plant construction. In 1940, the American aircraft industry employed approximately 46,000 workers. By 1943, aircraft manufacturing employed over 2 million workers. These were not experienced aircraft mechanics. Most had never worked in any factory before. Many were women, recruited to replace men who had entered military service. The iconic Rosie the Riveter imagery reflected a real phenomenon. Women operated drill presses, assembled subassemblies, riveted aluminum skin to airframes, installed engines and equipment, and performed every task in the plants except the heaviest lifting operations. Training programs were developed to turn inexperienced workers into productive employees within weeks. Simplified, standardized processes meant that complex tasks could be broken down into simple steps that did not require years of apprenticeship to master. Jigs and fixtures ensured components were assembled correctly. Quality control inspectors checked work at multiple stages. The system was designed to achieve acceptable quality from semi-skilled workers rather than requiring highly skilled craftsmen for every operation. It worked. Aircraft rolling off American assembly lines in 1943 and 1944 were consistently well-built, reliable machines. Defect rates were low. Performance met specifications. The aircraft performed their missions effectively. American industry had proven it could not only produce aircraft in unprecedented quantities, but could maintain quality while doing so. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The moment when German leadership could no longer dismiss American production claims did not arrive as a single revelation. It came as a gradual, grinding realization accumulated through intelligence, reports, aerial reconnaissance photographs, prisoner interrogations, and the undeniable evidence of American aircraft filling the skies over Europe in numbers that made effective resistance impossible. In 1941, the United States produced 19,433 military aircraft. This was already more than Germany's production that year, though German intelligence did not have accurate figures, and the disparity was not yet overwhelming. In 1942, American production reached 47,836 aircraft. This was nearly 3 times German production for the year, but most of these aircraft were still in the United States or being shipped to training bases and operational theaters. They had not yet appeared over Europe in massive numbers. 1943 was the year the reality became impossible to ignore. American factories produced 85,898 military aircraft that year. This total included fighters, bombers, transports, trainers, reconnaissance aircraft, and other types. The number included aircraft for the Army Air Forces, the Navy, and the Marine Corps. It included aircraft sent to Britain under Lend-Lease, to the Soviet Union, to China, to other Allied nations. The scale was simply beyond anything German planners had conceived possible. German aircraft production in 1943 totaled approximately 25,000 aircraft. This was actually an increase from previous years, as German industry under Albert Speer's leadership as Minister of Armaments and War Production was streamlining processes and expanding capacity. But German factories were producing 1 aircraft for every 3.4 aircraft American factories produced. The disparity was catastrophic. The types of aircraft matter as much as the raw numbers. The United States, in 1943, produced 13,991 B-24 Liberator, heavy bombers, and 6,185 B-17 Flying Fortress heavy bombers. These 4-engine aircraft could carry bomb loads of 4,000 to 8,000 pounds to targets deep in Germany, defended by armor plate, self-sealing fuel tanks, and up to 13 50-caliber machine guns each. Germany produced approximately 700 Heinkel 177 heavy bombers in 1943, the only German 4-engine bomber in production. The He-177 was technically sophisticated but plagued by mechanical problems and never achieved operational effectiveness in significant numbers. American production of fighters in 1943 included 12,361 P-47 Thunderbolts, a massive single-engine fighter that could escort bombers to targets in Germany and hold its own against any Luftwaffe fighter. Production of P-38. Lightnings totaled 2,724 aircraft, twin-engine fighters with exceptional range. P-51 Mustangs, which would prove to be perhaps the finest piston-engine fighter of the war, began large-scale production late in 1943. Germany produced approximately 10,300 Messerschmitt 109 fighters in 1943, along with approximately 1,700 Focke-Wulf 190 fighters. Both were excellent aircraft, but when facing 3 or 4 American fighters for every German fighter, excellence in design could not overcome numerical disadvantage. The photographic evidence became impossible to dismiss. Luftwaffe reconnaissance aircraft photographing American bomber bases in England brought back images that stunned German intelligence analysts. Airfields that had held dozens of aircraft in 1942 now held hundreds. New airfields were being constructed across East Anglia. The photographs showed hardstands, concrete parking areas for individual aircraft being built by the hundreds. Each hardstand represented one bomber station. Each airfield might have 40 or 50 hardstands. There were dozens of airfields. The mathematics were inescapable. German pilots returning from combat missions over Europe reported combat formations that seemed impossible. American bomber streams stretching for miles, with waves of aircraft following waves of aircraft. Fighter escorts in numbers that made it impossible to attack the bombers effectively. Even when Luftwaffe pilots shot down American aircraft, and they did, in substantial numbers during 1943, there were always more aircraft the next day, and the next week, and the next month. The Americans absorbed losses that would have crippled the Luftwaffe and returned with undiminished strength. Prisoner interrogations provided direct confirmation. American airmen shot down and captured spoke casually about production numbers that German intelligence had dismissed as propaganda. They described factories in Michigan and Texas and California producing aircraft by the hundreds per month. They mentioned that their training bases in the United States had more aircraft than some entire air forces. They talked about the assembly lines, the workers, the endless supply of equipment. German interrogators initially dismissed these accounts as attempts at psychological warfare, but the stories were too consistent, too detailed, too casual. The Americans believed what they were saying because it was true. Albert Speer, in his post-war memoirs, described the moment he realized the scale of American production. He had access to intelligence estimates, but he also had experience as an architect and industrial organizer. He understood what factory capacity meant. When he calculated what the Americans were doing, the number of facilities, the workforce size, the production rates per facility, he realized Germany could not compete. German industry could be made more efficient. Production could be increased, but there was no path to numerical parity with American output. The resource base was too different. The scale was too different. Germany was fighting an industrial war against an opponent that could outproduce German factories by factors of 3 to 1, 5 to 1, sometimes 10 to 1, depending on specific weapon systems. The German response was to attempt to make each German aircraft more effective than its American counterpart. Development of jet fighters, the Messerschmitt 262 promised aircraft that could outperform any Allied propeller-driven fighter. New tactics emphasized attacking bomber formations rather than engaging escort fighters. Concentration of fighters at critical points might achieve local superiority despite overall numerical disadvantage. All of these were attempts to overcome industrial reality through technical innovation and tactical brilliance. Some succeeded, temporarily, in limited ways. None changed the fundamental arithmetic. American production continued to accelerate. 1944 was the year American production reached truly staggering levels, numbers that seemed almost absurd even to those who had witnessed the build-up through 1942 and 1943. This was the year Hermann Göring's dismissive laughter from May 1940 turned to ashes. American aircraft production in 1944 totaled 96,318 military aircraft. This was more than all Axis powers combined produced during the entire war. To put this in perspective that is meaningful, American factories in 1944 produced approximately 264 aircraft per day, every day, including weekends, including holidays. For the entire year, the production broke down into specific types that reveal the scale more clearly. B-24. Liberator production reached 6,735 aircraft in 1944. B-17 Flying Fortress production totaled 6,358 aircraft. These two heavy bomber types alone, just two models, accounted for over 13,000 four-engine bombers produced in a single year. For comparison, Britain produced approximately 4,000 heavy bombers in 1944 across all types. Germany produced fewer than 1,000 heavy bombers that year. Fighter production was even more dramatic. Thunderbolt production reached 12,602 aircraft in 1944. P-51 Mustang production totaled 6,748 aircraft. P-38 Lightning production added 3,721 aircraft. American factories produced more than 23,000 first-line fighters in a single year, not counting Navy and Marine Corps fighter aircraft or less capable types used for training and secondary roles. The workforce that accomplished this numbered over 2 million people directly employed in aircraft manufacturing, with millions more in supporting industries producing aluminum, engines, instruments, radios, weapons, and the countless other components that went into military aircraft. The Willow Run plant alone, at its peak in 1944, employed 42,000 workers and produced approximately 400 B-24 bombers per month. The plant operated 3 shifts, 24 hours per day, 7 days per week. At peak efficiency, a completed bomber rolled off the assembly line every 63 minutes. German production in 1944 reached its wartime peak at approximately 39,400 aircraft. This was a remarkable achievement given the sustained Allied bombing campaign against German industrial facilities, the loss of territory as Soviet forces advanced from the east, and the resource constraints Germany faced. German industry under Speer's direction had become remarkably efficient at dispersing production into small, concealed facilities that were difficult to target. But efficiency and determination could not overcome the simple arithmetic. American factories produced 2.4 aircraft for every 1 German aircraft produced in 1944. The qualitative comparison makes the situation even more stark. German production included substantial numbers of trainers and obsolete types kept in service because nothing better was available in sufficient quantities. American production in 1944 consisted almost entirely of modern, effective combat aircraft. The B-24 and B-17 were mature, reliable designs produced in enormous numbers. The P-51 Mustang was arguably the finest piston-engine fighter produced by any nation during the war. The P-47 was rugged, powerful, and effective in both air-to-air and ground attack roles. Even the supposedly obsolete P-40, which had been America's frontline fighter in 1941, remained in production through 1944 for export to Allied nations and served effectively in secondary theatres. The impact on operations over Europe was overwhelming. By the summer of 1944, the 8th Air Force based in England could dispatch more than 1,000 heavy bombers on a single mission, escorted by hundreds of fighters. The 15th Air Force, operating from Italy, could launch similar raids against southern Germany, Austria, and the Balkans. The Royal Air Force Bomber Command added its own heavy bomber force, attacking at night while the Americans struck by day. German industry, German cities, German transportation networks, and German military installations were subjected to bombing campaigns of unprecedented intensity. Luftwaffe fighter pilots, even the most skilled and experienced, found themselves overwhelmed not by superior opponents, though American pilots were, and well-trained and increasingly experienced, but by sheer numbers. A German pilot might shoot down one American fighter, or two, or even three in a single mission. But there were always more. The Americans could absorb losses of 50 or 60 aircraft in a single day, losses that represented perhaps 5% of the attacking force, and return the next day with a formation just as large. The Luftwaffe could not sustain similar loss rates. Every experienced pilot killed represented months or years of training that could not be replaced. Every aircraft destroyed was more difficult to replace as production facilities were bombed and resources became scarce. German pilots interviewed after the war, those who survived, described the psychological impact of facing this endless stream of American aircraft. They knew they were outnumbered. They knew that even if they performed perfectly, shot down enemy aircraft without losses, the overall situation would not change, because tomorrow it would be more American aircraft. The knowledge was demoralizing in a fundamental way that affected combat effectiveness. Some pilots became fatalistic, taking desperate risks because caution seemed pointless. Others became overcautious, breaking off attacks to preserve their own lives for another day, reducing their effectiveness. The American numerical advantage created psychological pressure that German training and ideology could not counter. Göring himself, by 1944, had retreated from public view. The Reichsmarschall, who had once boasted that no Allied bomber would ever reach Germany, watched helplessly as Allied bombers struck German cities in daylight and darkness. His morphine addiction worsened. His influence declined. Hitler increasingly bypassed him, dealing directly with Luftwaffe field commanders. The confidence of May 1940, the dismissive laughter at American industrial claims, seemed to belong to a different world. 1945 brought the culmination of American industrial dominance, though the numbers themselves were lower than the previous year. American aircraft production in 1945 totaled 46,101 military aircraft. The decrease from 1944 reflected changing strategic priorities rather than declining capacity. The war in Europe ended in May. Japan's defeat was assured. The emphasis shifted from maximum production to specific types needed for the final campaigns and for occupation forces. Germany's aircraft production in 1945, before the surrender collapsed entirely. Perhaps 5,000 aircraft were produced in the first 4 months of the year before the Reich's industrial capacity disintegrated under the combined pressure of Allied bombing, Soviet advances from the east, and the general breakdown of the Nazi state. Factories were captured or destroyed. Transportation networks were severed. Raw materials were unavailable. The workforce dispersed or was conscripted into last-ditch defense units. The final tally of American aircraft production from 1940 to 1945 totaled 297,809 military aircraft. This number included aircraft of all types: heavy bombers, medium bombers, light bombers, fighters, transports, reconnaissance aircraft, trainers, and specialized types. It included aircraft delivered to American forces and aircraft sent to Allied nations through Lend-Lease. British Commonwealth forces received tens of thousands of American aircraft. The Soviet Union received nearly 15,000 aircraft, primarily fighters and bombers. Chinese forces received aircraft. Even smaller Allied nations received modern American equipment. Germany's total aircraft production from 1939 to 1945 was approximately 113,800 aircraft. This included all types, all purposes, all theaters. The ratio was approximately 2.6 American aircraft produced for every German aircraft. But this understates the disparity because German production included substantial numbers of obsolete types, trainers pressed into combat service, and emergency expedients. American production consisted overwhelmingly of modern, effective combat aircraft produced to consistent standards. The broader industrial comparison reveals the true scale of American mobilization. Germany produced approximately 67,000 tanks and self-propelled guns during the war. The United States produced approximately 88,000 tanks And this was not even America's primary armored vehicle focus. The United States also produced over 2 million trucks and other vehicles for military use. Germany produced approximately 160,000 artillery pieces of all types. The United States produced over 257,000. Germany built approximately 1,500 warships. The United States built over 7,000, including aircraft carriers constructed in months rather than years. The naval comparison is particularly striking. American shipyards launched aircraft carriers using the same mass production techniques applied to aircraft and tanks. The Essex-class fleet carriers were built in approximately 20 months, from keel laying to commissioning. The smaller Independence-class light carriers were built in 15 months, converted from cruiser hulls, originally intended for different purposes. The escort carriers, built on merchant ship hulls, were produced in as little as 3 months using prefabricated sections welded together. By war's end, the United States Navy operated more than 90 aircraft carriers of all types. Germany had no aircraft carriers. Japan began the war with 10 and ended it with none. The strategic bombing campaign's effectiveness remains debated by historians. Some argue the resources devoted to bombing Germany could have been better used elsewhere. Others note that German industrial production actually increased through 1944, despite sustained bombing. But what is beyond debate is that Germany had to devote enormous resources to air defense fighters, anti-aircraft guns, radar systems, personnel that could have been used elsewhere. Perhaps 1/3 of German artillery production went to anti-aircraft guns. Hundreds of thousands of personnel operated air defense systems rather than serving at the front. The campaign forced Germany to fight a defensive air war over its own territory, with resources it could not spare. The psychological impact on German leadership was profound. Albert Speer described in his post-war writings the growing sense of futility as American production figures were updated monthly. German intelligence had stopped dismissing the numbers as propaganda. The evidence was too overwhelming, but knowing the truth did not provide solutions. Germany could not match American production. It could not prevent American aircraft from dominating the skies over Europe. It could not stop the bombing campaigns that disrupted production, destroyed infrastructure, and killed hundreds of thousands of German civilians. The knowledge of American industrial capacity became a source of despair rather than motivation. Göring's descent into irrelevance accelerated through 1944 and into 1945. Hitler stripped him of most authority. Other Nazi leaders openly mocked him. His prediction that no Allied bomber would reach Berlin was thrown back at him after every raid on the German capital. His dismissal of American industrial capacity in May 1940 became evidence of his incompetence. In the final days of the Reich, Hitler expelled Göring from the Nazi Party for attempting to assume leadership as Soviet forces closed on Berlin. Göring survived the war, was captured by American forces, and stood trial at Nuremberg. He was convicted of war crimes and crimes against peace. He committed suicide by cyanide capsule hours before his scheduled execution in October 1946. The factories that had produced the aircraft, the workers who had built them, the supply chains that had fed the production lines, all of this infrastructure remained after the war ended. America emerged from World War II as the world's dominant industrial power. The Soviet Union had suffered catastrophic damage to its industrial base. Britain was exhausted economically. Germany and Japan were occupied and devastated. China was descending into civil war. Only the United States possessed intact, modern industrial capacity on the scale developed during the war. The human element of American aircraft production during World War II deserves particular attention because it reveals what the numbers actually meant in lived experience. 2 million people working in aircraft manufacturing were not abstract statistics. They were individuals who had been farmers, shopkeepers, students, homemakers. They learned to rivet aluminum, install hydraulic systems, wire radios, assemble engines. They worked shifts that disrupted normal life. They endured industrial accidents, fatigue, pressure to meet production quotas. They made the numbers possible. The women who entered aircraft factories during the war, often called Rosie the Riveters after the propaganda figure, represented a profound change in American society and industry. Before the war, heavy manufacturing was almost exclusively male. The assumption that women could not perform industrial work was widespread and largely unchallenged. The labor shortage created by military mobilization forced a reconsideration. Women were recruited, trained, and employed in every aspect of aircraft production. At Willow Run, women comprised approximately 40% of the workforce at peak production. They operated drill presses, assembled wing sections, riveted fuselage, panels, installed engines, tested systems. They worked 3 shifts around the clock. Many were married women whose husbands were serving overseas. Others were young women who would have entered domestic service or clerical work in peacetime. The factory paid them industrial wages, substantially more than traditional women's jobs. This economic independence was transformative for many. The work was not easy. Aircraft manufacturing, even with simplified processes, required precision and attention. Mistakes could be fatal to the workers in the factory or to the crews who would fly the aircraft. Quality control was rigorous. Inspectors checked work at multiple stages. Workers who could not maintain standards were reassigned or dismissed. The factories were loud, with the constant noise of riveting guns, metal cutting, engines being tested. The smell of aluminum dust, hydraulic fluid, and aviation fuel permeated everything. In summer, the vast factory buildings became oppressively hot. In winter, they were cold despite heating systems. Accidents were common. Pneumatic tools could slip and cause injuries. Workers fell from scaffolding. Moving machinery caught clothing or hands. The safety record improved over time as training programs were refined and safety procedures were implemented, but industrial work remained dangerous throughout the war. The injury rate at Willow Run in 1943 was approximately 13 injuries per million man-hours worked. With 42,000 workers on site, that translated to several injuries daily, ranging from minor cuts to serious accidents requiring hospitalization. Despite these challenges, workers achieved remarkable productivity. At peak efficiency, Willow Run produced 1 B-24 every 63 minutes. This meant that every hour, around the clock, a complete 4-engine bomber weighing 32,000 pounds, containing approximately 1,450,000 parts, rolled off assembly line. The bomber was fully equipped with 4 Pratt & Whitney R 1820 engines, 13 50 caliber machine guns, bomb racks, radio equipment, navigation instruments, and all other operational systems. It was ready to be flight tested, then ferried to modification centers for final equipment installation, then deployed to operational units. The accomplishment becomes more impressive when considering that many workers were new to industrial labor. Training programs typically lasted 4 to 6 weeks before workers were assigned to production positions. They learned on the job, under supervision from more experienced workers and foremen who had often come from the automobile industry. The standardization of processes meant that relatively inexperienced workers could produce acceptable results if they followed procedures carefully. The system was designed around this reality. After the war ended, most women workers were laid off as men returned from military service and reclaimed industrial jobs. This was expected and largely accepted at the time, though it represented a significant economic loss for women who had become accustomed to industrial wages. Some historians argue the war experience planted seeds for later movements toward gender equality in employment, though the immediate post-war period saw a return to traditional gender roles in most sectors. The factories themselves faced uncertain futures. Willow Run had been built specifically for B-24 production. When bomber production ended in June 1945, the facility's purpose ended with it. The plant sat largely idle for months before being converted to other uses. Parts of it were eventually used for automobile production. Parts became warehousing. The vast building that had produced the world's most advanced bombers became, in peacetime, just another industrial space seeking tenants. Other facilities transitioned more smoothly. Boeing's Seattle plants shifted to commercial aircraft production, building on wartime experience to develop the commercial airliners that would dominate the post-war aviation market. Douglas aircraft transitioned to civilian transports and continued military production during the Cold War. Lockheed, North American, and other companies remained in aerospace, sustained by military contracts for jet aircraft, missiles, and eventually spacecraft. The expertise developed during the war did not disappear, it evolved. The workers dispersed to other jobs, other lives, other challenges. Many veterans of aircraft production plants later spoke about their wartime work with pride. They had contributed to victory in tangible, measurable ways. The aircraft they built had flown missions over Europe and the Pacific. Those aircraft had protected ground forces, destroyed enemy industry, brought the war to enemy territory. The work had mattered. For many, particularly women who had experienced independence and industrial wages, the return to traditional roles was difficult. They had proven they could do the work. They had demonstrated capability that pre-war society had denied. That knowledge did not disappear even if the opportunities did. The legacy of American wartime production extended far beyond the immediate post-war period. The organizational techniques, the management systems, the production engineering expertise, all of this became part of American industrial knowledge. The generation that had mass-produced aircraft in unprecedented quantities would go on to build the post-war American economy, applying lessons learned under wartime pressure to commercial production. Hermann Göring's laughter in May 1940 at Roosevelt's announcement of a goal to produce 100,000 aircraft per year was not the sound of a fool ignoring obvious truth. It was the sound of a man whose understanding of what was possible was constrained by his own experience and the capabilities of the system he knew. German industry was efficient, disciplined, and increasingly productive under wartime mobilization. Göring had every reason to believe that German production represented the practical limit of what industrial society could achieve. He was wrong. The wrongness was not in failing to predict the future accurately. Predicting exactly what American industry would accomplish would have required understanding systems and capacities that existed nowhere else in the world. The wrongness was in dismissing the possibility that America might be fundamentally different in industrial character and scale. German intelligence made a category error. They evaluated American capacity using German standards, when they should have recognized that American industry operated according to different principles. The automobile industry's mass production techniques, developed over decades in peacetime competition, proved transferable to weapons production in ways that European industrial systems could not match. The American approach, breaking complex products into simple tasks, using semi-skilled workers with specialized tools, organizing supply chains for maximum efficiency, accepting standardized designs over custom production, had been refined to extraordinary effectiveness in the civilian economy. When applied to military production, these methods achieved results that seemed impossible to observers familiar with traditional manufacturing approaches. The scale of American production, 297,809 military aircraft in approximately 5 years, represented more than industrial capacity. It represented resource abundance, geographical security, and societal organization that could mobilize millions of workers for sustained effort. America had population, raw materials, energy, industrial capital, technical knowledge, and organizational systems that could be combined for unprecedented output. Germany possessed some of these elements, but not all. No other nation possessed all of them in combination. The psychological impact on German leadership of discovering the truth about American production cannot be overstated. Speer described the realization as crushing. Germany could not win an industrial war against an opponent that could outproduce German factories by factors of 3-1 or 5-1, depending on specific weapon systems. This knowledge came gradually, through intelligence reports and combat experience, but by 1943 it was undeniable. The strategic implications were catastrophic. Germany could not achieve air superiority over Europe. It could not prevent bombing campaigns against German industry and cities. It could not sustain attrition in equipment and trained personnel at rates required to contest Allied dominance. The aircraft production disparity was emblematic of broader industrial differences. In tanks, in artillery, in trucks, in ships, in every category of military equipment, American production met or exceeded German production, while also supplying Britain, the Soviet Union, and other Allied nations. The combined Allied industrial capacity was overwhelming. Germany's hope for victory rested on achieving decisive results before Allied numerical advantages became insurmountable. That window closed in 1943. For the workers who built the aircraft, the victory was personal and collective. They had done something that many believed impossible. They had transformed an economy oriented toward civilian production into the most productive military economy in human history. The aircraft they built flew missions that shortened the war. Every bomber that struck German industry, every fighter that escorted bombers to target, every transport that carried supplies to frontline units, these aircraft existed because American workers had learned to produce them in quantities that defied pre-war assumptions about what was possible. The factories, the production lines, the standardized processes, the trained workforce, all of this represented a kind of mobilization that was distinctly American. It was not primarily about superior technology, though American aircraft were generally equal or superior to German equivalents. It was not about superior design, though American engineering was excellent. It was about scale, organization, and the ability to turn industrial potential into actual production at rates that seemed absurd until they were achieved. When the last aircraft rolled off American production lines in 1945, when contracts were cancelled and workers were laid off and factories shut down or converted to peacetime production, the numbers spoke for themselves. Roosevelt's impossible goal of 100,000 aircraft per year had not only been achieved but exceeded. In 1944 alone, American factories produced 96,318 military aircraft, just short of 100,000 in a single year. Over the full period of American involvement in the war, production averaged approximately 60,000 aircraft per year, well above the initial goal that had seemed so laughable to German leadership. Göring had laughed at American claims in May 1940 because he could not imagine an industrial system that operated at such scale with such efficiency. By 1944, he was not laughing. He was watching American aircraft fill the skies over Germany, knowing that every aircraft shot down would be replaced, that every loss sustained by the Americans was a minor setback while every German loss was irreplaceable. The laugh had turned to silence, then to despair, then to the final collapse of the regime he had served. The story of American aircraft production during World War II is ultimately a story about the difference between what seems possible and what actually is possible when circumstances demand maximum effort. It is a story about industrial capacity as a strategic weapon. It is a story about ordinary people, farmers, shopkeepers, homemakers, students becoming industrial workers and producing equipment that changed the course of history. It is a story about numbers that seemed like propaganda becoming numbers that were documented fact. And it began with one man's dismissive laughter at a goal that seemed absurd until American industry proved it was not absurd at all. It was simply what needed to be done, and so it was done. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.